Okay, this is 8.2 number 14. It's calculator active. Mr. Kelly and Mr. Sullivan are doing a morning speed walk race going down a straight street. Okay, so it's going totally straight from 0 to 20. Mr. Kelly's velocity is given by the equation K of t. So K is his velocity. Mr. Sullivan's velocity at time t is given by S of t. Both K of t and S of t are positive from 0 to 20, so they're both going in the positive direction the entire time. They're measured in yards per minute. And Mr. Kelly has a 5-yard head start at t equals 0. And is ahead of Mr. Sullivan the entire time from 0 to 20. Okay. Find the value of 1 over 5 of the integral from 10 to 15 of k of t dt using correct units. Interpret the meaning. Okay, I'm going to put it in my calculator. Since there's a lot of questions regarding these equations, I'm going to save this in my calculator so I don't have to type it every time. Let's see. If you're using NumWorks, you're going to save it as like f of x, g of x, something like that. If you're on your TI, you're going to save it as y1. I would make a note here which one you're saving it as so that when you're using your calculator, you remember. I'm going to use it NumWorks, so I'm going to call this f of x. And I'm going to save Mr. Sullivan's velocity as g of x. And I'm just making a note for myself. So when I put this in the calculator, I'm going to do 1 over 5, the integral from 10 to 15 of f of x dx to get my answer. Okay, the calculator gave me 99.8324. Okay, using correct units, interpret the meaning of the expression in the context of the problem. Okay, if it were just the integral of the velocity, I would say it's this displacement. But this little 1 over 5 in the front makes me think it's average value because 15 minus 10 is 5. So I think this is the average value formula, which means it's the average value of whatever K is. K is Mr. Sullivan's velocity. So this is Mr. Kelly's average velocity. And it's average velocity because it's the average value of K, and K happens to be Mr. Kelly's velocity. Is 99.8324. Since this is the average value of K, it is the same units as K. K is yards per minute. I'm going to say from t equals 10 to t equals 15 minutes. Okay, let's go to B. At time t equals 7, is Mr. Kelly speeding up or slowing down? So if I want to know speeding up or slowing down, I want to check V and A. I want to see if V and A have the same signs. Okay, the velocity for Mr. Kelly is the K function because K is already the velocity. So I'm going to do K of 7 in my calculator. Since I saved K as F, I'm going to do F of 7 in my calculator. Okay, I got K of 7 is 186.7995. And then as I was plugging it in, I remembered that they actually told me K is always positive. So I didn't actually have to plug it in. I could have just said K of 7 is greater than 0. Okay, acceleration is the derivative of velocity. The velocity is K, so I want K prime of 7. This one I am going to plug into my calculator to get the actual value. Okay, I did derivative. I used my save function, and I got negative 19.0331. Okay, so I can see that V and A have opposite signs. So what is the question? Mr. Kelly is slowing down. Because K of 7 and K prime of 7 have opposite signs. And when you mention this, you need to at least mention somewhere that t equals 7, because it's not true that they are always opposite, but at that moment in time, they are opposite. Okay, part C, is the distance between Mr. Kelly and Mr. Sullivan at time t equals 7 increasing or decreasing? Give a reason for your answer. Okay, normally I would write an equation for the distance, and then I would see if d prime is of 7 is positive or negative. They didn't give me an equation for distance. I'm going to make up my own equation. Okay, I'm going to say the distance between them is, I want to say Mr. Kelly's position and Mr. Sullivan's position. But S is already Mr. Sullivan. I'll call it X. Okay, so I'm calling X sub K Mr. Kelly's position minus Mr. Sullivan's position. Wait, let me double check. Is Mr. Kelly ahead of Mr. Sullivan? Yes, Mr. Kelly has a 5-yard head start and is always ahead of Mr. Sullivan. So the distance between them should be Mr. Kelly's position minus Mr. Sullivan's position. Okay, I want to see whether this is increasing or decreasing. So I want d prime. Now I don't know X, but X is Mr. Kelly's position. So if I do the derivative of his position, I should get his velocity, and the equation for velocity of Mr. Kelly is K. Okay, X sub S I made to be Mr. Sullivan's position. I don't know an equation for that, but I know the derivative of Mr. Sullivan's position is his velocity, and the equation for his velocity is S. Okay, so even though this looks crazy, I'm trying to see if d prime of 7 is positive or negative, which means I want to know if k of 7 minus s of 7 is positive or negative. So I'm going to do k of 7 minus s of 7 in my calculator. And because I saved the functions, I'm really doing f of 7 minus g of 7 in my calculator. Okay, I did k of 7 minus s of 7, and I got negative 24.02832. So is the distance between them increasing or decreasing? Okay, distance between them is decreasing because d prime of 7 is less than 0. They didn't give me d prime in the equation, but because right here I said d prime equals k minus s, it's okay for me to say d prime of 7, because I already told them d prime of 7 is the same as k of 7 minus s of 7, because the algebras wrote k of 7 minus s of 7 is less than 0. Okay, last question. Okay, what is the maximum distance between Mr. Kelly and Mr. Sullivan over the time interval 0 to 20? Justify your answer. Okay, I want to do the maximum distance. So I need the critical numbers for distance. Okay, so let me set d prime. Let me see what d prime is. I found d prime in the last problem. So d prime I defined as k minus 6. So I want to see when d prime equals 0 so I can get the critical numbers. So I want to see when k minus 6 is s is equal to 0. I'm going to use my calculator to solve that equation. So on my calculator, I can use the solver or I can use the grapher. If I have a numworks, I can go to equations and use the solver because I saved k as f of x and s as g of x. I can do f of x minus g of x equals 0 and have it solve the equation for me, and that's fine. If you have a TI or a numworks, actually, you could do, when you do the grapher, you're going to, on y3, you're going to do y1 minus y2. And you're going to graph that, and you can either find the zeros or you can go to y4 and graph equals 0 and find the intersection. If you don't want to see the y1 and y2 graphs, you hit the equal sign, you unhighlight the equal sign so it won't show up on the graph. Yes, it's a lot of work. Okay, I'm going to write down the answers. Okay, when I solve it, I get t equals 3.9268 and 8.2469 or 7, depending on if you round or truncate. Okay, now I want the actual distance. These are just the critical numbers, and further, they have given me a closed interval, which means I need to check the endpoints as well. Okay, so now I actually do need the equation for the distance between them. Okay, so on the previous problem, I said the distance was Mr. Kelly's position minus Mr. Sullivan's position. But I didn't actually define them, so let me define them real real quick. Oh, so Mr. Kelly, he starts out 5 ahead. So he's going to be 5 plus his distance from 0 to, depending on the time, of k of t dt. He starts at 5. If I integrate his velocity, I'll get his displacement. Okay, Mr. Sullivan, he starts after Mr. Kelly is 5 ahead, so I'm going to say it's from 0 to t, s of t dt. Okay, now what is distance? I said the distance was Mr. Kelly's position minus Mr. Sullivan's position because Mr. Kelly is always ahead of Mr. Sullivan. Okay, so d equals 5 plus the integral from 0 to t k of t dt minus Mr. Sullivan's position. Okay. And then I need to check several points here. And we're going to make a table just because there's so many points. T, D. So I need to check the endpoints, which are 0 and 20. Although 0 I already know is 5 because they had a 5 yard head start. And then I also need to check the critical numbers, 3.9268, 8.2469. Okay, so in my calculator, I have to type 5 plus, I'm going to do 20 first, 5 plus 0 to 20, whatever you saved k as, f of x dx, minus the integral from 0 to 20 of g of x dx, and I'm going to get my answer. Okay, the answer I get is 959.6664. Okay, now that was a lot to type. So you're going to like highlight it and hit enter, or you're going to do second enter on your TI so it will retype this for you. And I'm going to back arrow and change this to 3.9268 and this to 3.9268. And then I'm going to hit enter again. And this time I get 533.0478. Okay, and then I'm going to hit second enter, or I'm going to highlight it and hit enter again and retype this again. And this time I'm going to go back, delete this, make it 8.2469. Okay, and then I'm going to get 428.7898. Okay, and now I'm going to answer the question. Okay, so what is the maximum distance? The maximum distance is going to be that one. So let me answer the maximum distance between Mr. K and Mr. S is 959.664 yards. Okay, and then it says justify your answer for extreme value theorem. Your justification is that you checked the endpoints and the critical numbers, listed all their values to prove that you have taken the highest of the values.